We're back with an upgrade to the child warning system, and this time it looks and works like something I didn't just put together in 5 minutes. The goal was to make it smarter, cleaner, and maybe even figure out which kid is sneaking in. Did it work? Sort of. It's definitely an upgrade with some fun additions along the way. Let's get into what's new. Originally, I installed an ultrasonic sensor on the side of my door that lights up a red light on my desk every time someone walks in. The way I position my desk makes it super easy to scare the death out of me, especially if I'm concentrating on something. Add that to me having 4 kids that just love to make me jump, and you have a ticking fright bomb. There were a few problems with the initial design: position of the sensor, the actual case, the relay switch that clicks every time someone walks in. All in all, a crappy job. I started by removing the old setup. I'm still going to use the elegant holes I drilled last time to wire everything from the entrance up to my desk. Let me try and explain what we're going to do here. I have an LCD screen and I've got my red lights. In the previous child warning system project, I put the sensor on the side of the door and it detected every time someone went through. Now I'm going to make it a bit more effective. I'm going to put it on the top of the door frame and it's going to measure height. I know the height of each one of my family members and I'm going to write on the display who's entering the room. Obviously the red light will still catch my attention. It will be turning on and off every time it detects someone coming in. The door frame is 80 centimeters wide. My kids are sneaky. They'll definitely catch on recognizing who's coming in, and they're going to try and sneak in from the sides of the door. They're going to try and crawl. I need to do something about this. So instead of putting one ultrasonic sensor on the top of the door frame, I'm going to put 2. So it's going to be 2 ultrasonic sensors at the top of the door frame, and they're going to overlap, and I will take the maximum value of either one of the 2. So if someone tries to come in from the side, this sensor will catch on. If they try and come in from the other side, I've got another sensor to catch them, and I will know how tall the person that's walking in is. Now, I've designed a holder for the sensors. This holder will allow me to do 2 things. First of all, it makes sure that the sensor is completely parallel to the ceiling or completely parallel to the floor. And I've also got holes on the side that will let me run the cables through the 2 sensors. I've also got this 6-wire wire. Each sensor needs 4 pins. That's a total of 8. But 2 of the pins are VCC and ground, so I can connect the 2 VCCs to 1 wire and the 2 grounds to 1 wire, and that brings us to 6 wires all in all, right? So this will run from the entrance all the way up to my desk, and all I need to do is bundle all this into some good looking stand and we're good to go. It's actually easier than I thought it would be. Soldering onto the actual sensor pins. I've already finished the first sensor and I'm already teed the red and black wires, and it actually came out pretty good. Oh, look at that. Happy about that, very happy. That's what happens when you buy crap off AliExpress instead of buying something a bit high quality. It just keeps falling off. Really need to get some white zip ties. It's just like completely cramps my style if it's black over white like it is now. We don't want that, do we? Style cramping. Hammering is by far the hardest task in maintenance, at least for me. For every nail I'm able to fix in the wall, there are about 6 that fall to the ground after I either hammer one of my fingers or break a substantial part of the wall. Okay, so as always, ChatGPT is a fantastic help. All you need to do is write down what the actual diagram or circuit is meant to do, and it will give you the pinouts, how to connect everything to the Arduino, and the code you need to put into the actual Arduino IDE. It's so easy. I don't know how to code with Arduino. I could have learned it if I wanted to, but there's no need to, because ChatGPT takes you up that one level and just saves all that time. So I don't really need to learn it. It all makes sense. It's not complicated. I've known loads of people that use the actual Arduino to plan DIY projects. Definitely doable, but like I said, if you've got the option to use ChatGPT, which everyone has these days, you should do it. Connected the entire circuit, okay? Arduino, LCD screen, a dimmer for the LCD screen, a relay switch that will turn on and off the red light via a 24-volt adapter. All this has been connected. It took me 10 minutes. At the moment, it's on a breadboard, which is basically a very easy option to just connect everything together straightforward, so it's really fast. So before I do all this soldering, which is basically the step where there's no going back. So once I've soldered, that's it. I want to make sure that the circuit works. The circuit has been constructed on my workbench, but we are actually going to be positioning the box on my computer desk. And I've already wired the sensors over to there. So in order to check that everything's working before soldering, I need to take all the setup and put it over there. So we're going to do that now. I'm all set up. Let's quickly go over it again. The Y cable brings in the signals and the power supply for the sensors, and it's connected directly to the Arduino, and the breadboard gives the power supply. All the power supply goes through the breadboard on one straight line for 5 volt and one straight line for ground. I designed this box, and it's going to sit on the desk. And it's got an angled hole for the LCD, so that I'll be able to see it while I'm working. The Arduino will just be inside the box with the relay switch. Okay. I left the back wide open for all the cables to come out. The cables that need to come in here are cables coming from the sensors, the room entrance, and power for the Arduino. Yeah. Okay, now the lid that will be on top of the box will hold the light here on top. Let me show you. So the light will sit here. The cables will be able to just go through the hole that I made and be wired accordingly to the Arduino, to the relay, outside to the power supply and everything. Something like that. Now, this is the LCD. We'll check in a sec if it fits. But look what a mistake I made. Such a common mistake. But this design, I think, is perfect. Meaning I've not tried the LCD yet, but I'm pretty sure it's going to fit in perfectly. And there's enough room for the Arduino and the relay, and it looks really good, right? The lid was meant to just sit snugly on a ridge that I made. This is the ridge. You see the ridge? But the lid doesn't fit. It fits inside the ridge, but it's much too long for the top. Do you know what mistake I made? I made it according to the bottom dimensions, not taking into consideration the angle of the LCD screen. So at the bottom, it's perfect. On the top, it's not. So I'm printing over there another lid, updated sizes, and then we'll be good to go. But let's talk about the LCD. The LCD needs to be connected through too many wires to the Arduino, but that doesn't matter because it's going to be behind the screen. The LCD has jumpers that come out from here, and it also has, I think it's the light, the backlight here, that's also, you see that? Yeah, the backlight also is coming off the PCB board. So I needed to make inside the design holes for these two elements. But let's see if it fits. Wait, don't judge yet. There we go. Wow. So that's what it looks like. It's a perfect fit. First time. So this is big, and it doesn't happen every time. But sometimes you can design something once and it comes out perfect. Sometimes. I'd say 1 in 20 will just come out perfect. It's heavily based on how much thought you put into it and how much time you take when taking the measurements, because you can always recheck yourself, but you don't always do that. If you do, you minimize the mistakes at the end. With 3D printing, it's not that big an issue. I mean, you can prototype so fast. Even if I made a mistake, this print took 7 hours, okay? Not that big a deal, but when it works out, it's the best feeling ever. We'll have the Arduino in here, just be snugly back there. The relay will be in here, and then we'll have the lid that will also be a perfect fit. And finally, the lights. I found these great wire connectors that save a ton of time soldering. The only downside was that if you push a jump wire inside, it will never come out. But I could live with that as long as it saves me unnecessary soldering. I then started making up funny excuses to make my family members walk in and out of the door frame to record a few measurements. This soon turned into a carnival. The kids were fighting who will go first. They were interrupting each other and doing crazy things. It's amazing how kids can fight about everything. They had no idea what I was asking them to do, and it was still a reason to fight. The results were inconclusive. There is no way I can determine the exact height of the person walking in, especially when it's hopping, running, or stumbling kids. For now, what I did was differentiate between grown-up and child, which is one step closer to the ultimate goal. The next thing would be to filter and average the readings of the sensor. The sensor is working at a pretty high rate. The code I got from chat is just choosing one of these values. If I filter and average it, I will get a better and more accurate result. I mean, a walking human with hair is a pretty hard nut to crack. Now, the LCD screen is going to be on at all times. In order not to waste this precious screen time, I asked chat to conjure 1,000 sentences about life and success, and it projects these sentences every 10 seconds randomly. This has been a significant upgrade to the first version. With that said, it's a work in progress. I'm definitely not done. I will try and smooth out the readings to try and get a really accurate height measurement. Let me know in the comments if you have any good ideas what I can display on the LCD screen apart from computerized pet talks. The next video will be another fun addition to this setup, solving an issue I have regarding my wife calling me in the middle of the night. Thanks for your time, subscribe, and I will see you on the next one. But do subscribe.